Good morning, everybody. Good morning, good morning, good morning. So we shall be observing chemistry class right now for the JAM students. Exactly. So that is what we have to do right now. So you all should prepare and get ready. We have a lot of things to discuss about here this morning. Thank you very much. Stay tuned. Stay tuned. Stay tuned while we prepare for the class. I want to be sincere with you right now. We have many related problems to solve. You can please report the condition of my screen. If it is clear, you can see my screen very well, let me know. And if you cannot see my screen very well, please let me know so I can do the necessary adjustments from my hand as well. It's very, very important. So while awaiting others to join, please, you can kindly forward this information along to others that need to know as well that we are live right now on YouTube. We are live right now. We are live right now. So you are welcome to where we are going to be discussing more of organic chemistry this time around. That is what I want you to get clearly right now. So this class will be basically on what we call the alkana and the alkanone. which has to do with the organic chemistry too on its own. So without wasting much of our time, let's begin what we are here for. Now, let's talk about this, which is very, very important. Um, we're going to be talking about what we call the carbonyl group. Alkanal and the alkanone. Okay, so when we're talking about the alkanal and the alkanone, this is what I want you to understand carefully from this mentioned compound. It should be noted that we are dealing with what we call organic chemistry. Of course, there are a series of questions here that you can come across under your JAM questions and why questions, related to this. Now, when we're talking about the carbonyl group, from the name carbonyl group, it simply means they have this. We have C and O is present in them. That's the major reason why we call them the carbonyl group. However, if we are to define this in accordance to their nature, we have to understand this carefully, that this mentioned carbonyl group for the alkanal, they have the functional group of CHO. That is the functional group of the alkanal. Take note of that. Meanwhile, for the alkanone, they have the functional group of the CO. Take note of that. That is our functional group. So if you want to write the general molecular formula of the alkanal, the general molecular formula of the alkanal is given to be RCHO. So which can also be rewritten in the structural form of RC, followed by we're going to have double bond O, followed by you have H here. That is the forms of this one here. Now, if you want to rewrite the general molecular formula for the alkanone, you are going to have the general molecular formula of the alkanone, where you are going to have RCO. And if you restructure this, you are going to have R followed by C, and then we have what's called double bond O in that place. Now, as you can see, the differences between the two is the presence of what's called the hydrogen atom, which is attached to each what's called of the alkanal, and it's not attached to the what? To the alkanone. That is exactly what you have to understand there. Now, from what we have in this place, let us now go further and discuss about the definition of the alkanal. Okay. Now, when we're talking about the alkanal have a general molecular formula, which is the RCHO. That is their own general molecular formula, the RCHO. Now, and their functional group with functional group COO. HO. That is the functional group that is present in there. So they are classified under what we call the Carbonyl group. Take note of that. That's where they are classified as the Carbonyl group. Okay. So the next thing we have to discuss about in this place is, let's talk about the homologous series. Homologous series of alkyl. The homologous series of the alkyl includes this one that we have here right now. We have the homologous series. Take note of that. Now, the first member that we have there, we can have what we call the methanol. The methanol has the molecular formula. Take notes from each member where we are going to have what we call the C, followed by, you can have H here, then you can also have, in this place, you are going to have H followed by O. But it should be noted carefully as when drawing the structure, one have to be careful in attaching so that there is no problem at the end of the day. So if you want to write the molecular formula will be in form of C followed by H2 followed by OZ. Take note of that. So C is 1, H is 2, O is 1, with the structural formula is C followed by base as the structural formula. The next one that you have there is called the ethanol. The ethanol, take note of that. From the first member, there we go. We are going to have C followed by CH3. Take note of that. The CH3 followed by CHO. So if you want to obtain the what we call the molecular formula now, the number of C there is how many? The number of C there is 2. That's C2. The number of H there is how many? That is a 4. The number of O there remain 1. So you can transfer this to this to have CH3, CHO. Now, the next compound that you also have in this place is called the propanol. This propanol will go in this direction, CH3, CH2, CHO. And how many carbon atoms do you have in total? C3, followed by, we have 6 there, we have O there. The next one that we are going to have there, you continue to arrange it in that continuous form, So the next one that will follow after the propanol is going to be the butanol. Okay, so this butanol that you have in this place can be written in this manner for the butanol. There you have. What you are going to have here is arrange the 4 carbon atom, CH3, CH2, CH2, CHO. So after this arrangement that you have here, then what are you going to do next? You can derive the molecular formula 1, 2, 3, 4, C4H. The number of H there will be 7 followed by O. Then you proceed on and on and on like that. So that is the arrangement of those mentioned one there. This is from methanol, ethanol, propanol, butanol. So let me add one more to it to make it methanol, making 5. Then methanol. So this pentanol here, we have what we call the CH3, CH2, CH2. This is 3. It remains 2 more. I'm going to have CH2, CHO. Now, the number of the carbon atom will be 5. The number of hydrogen atom will be 8. The O remains in that place. We count everything here. This is 6. 3 plus this will give you 5. 1, 2, 3, 4, 5. So 3 plus this to give you 5, 6, 7, 8, 9. Then we are going to have 10 there. So you do the arrangement. For this pentanal, it has what we call a 5 carbon atom. So 1, 2, 3, 4, 5. And for the number of hydrogen atom, H here, H, 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 H. Then come to this place, you have your double bond O, you have H in this place. So how many H we have in total here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that means our H here will be 10, while the O remain 1 there. Okay, so for the butanol that we have in this place, that should be 4, 1, 2, 3, 4. There we go. Say we are going to have double bond O, we are going to have H here. 1, 2, 3, 4, 5, 6, 7, 8. That is exactly what we have there. So with respect to this arrangement that we have here, this is how we arrange those related to what we call the mentioned canal. So you can continue to arrange them in order, continue to arrange them in order. So then after that, let us now proceed and look for the arrangement in connection to what we call the R canal, which has to do with some related properties. But before then, I would like to tell you this. What is that? When we're talking about the R canal, another name for the R canal is called the aldehyde. Take note of that, aldehyde. So we can have methyl aldehyde as another name. We can have ethyl aldehyde as another name. Propyl aldehyde as another name for the propanol. Then we can have butyl aldehyde, another name for butanol. And also we have pentyl aldehyde, which is also another name for pentanal. So these arrangements here will continue to give you exactly what those compounds are. Okay, so here we go. Let us proceed. Now, I would like to discuss about this carefully. When it comes to the alkanal, I've mentioned it earlier that their functional group is CHO, unlike those of what we call the alkanone, which their functional group is CO. And so the two of them, we refer to them as what we call the carbonyl group. Okay, so the next thing we are going to be discussing about concerning this mentioned compound there is that we are going to be talking about their similarities. What are the similarities between the two of them? Now, the similarity between the two of them is the presence of the carbonyl group, which I've mentioned earlier, the carbonyl group. That is the similarities between the two of them. Okay, so but it should be noted that hydrogen atom is attached to the alkanal, while hydrogen atom is not attached to the alkanone at the rear ends. At the rear ends. Take note of that there. Okay, now let's talk about other related compounds that we have there that we can discuss about. So let us discuss about what we call the alkanone now, before we now move into the properties and preparation of this mentioned compound. Alkanone. Now the alkanone have the general molecular formula. It has general molecular formula. The general molecular formula RCO. Now, and functional group, the functional group is CO, which is referred to as the what? Carbonyl group. which is present there. Now, there's no attachment of hydrogen atom to this one here, no attachment of hydrogen atom. Okay, so let's discuss about what are the members that we have in this place. Now, the members that we have here has to do with those that are present with respect to their carbon atom, which is very, very essential. We need to discuss about this to know what are the members that we can come across here. Now, those members that we can come across in this place does not start with the first carbon atom, which is the methyl. Rather, these members that we're discussing about here, they start with those with 3 carbon atoms. Yes, those that begins with 3 carbon atoms. So the members that we have in this place begins with what we call the propanone. Exactly, the propanone. Now, if we are to go into this, the first member, first member there is called propanone. Propanone. So from the word pro, there we have double bond O, we have H here, H, present there. We also have H here, and H present here, which is CH3, CO, CH3. That is the first member that we have there that is present in the mentioned compound. Okay, another member that we also have in this place is referred to as the butanone. It should be noted that this one that we named here has to do with 1, 2, 3, the position of the functional group there. So, which is commonly referred to as the propan 2-one. Take note of that, propan 2-one. That is what we commonly call the compound. Now, another one that we also have in this place is referred to as the butanone. Butanone. C. We have double bond O here, H here, H. Okay, so this one that we have here, the numbers of carbon atom is 1, 2, 3, 4, and so this is referred to as the butanone. But the position of the carbon, the position of the functional group, there is our position number 2. That is butanone. Take note of that, which is also referred to as butanone. Now, since we have looked at this mentioned compound here, there are many related compounds that we also have there that also have this mentioned name. Take note of that also have this mentioned name. So, with respect to that, let us discuss about this very well. Let us discuss about this very, very well. Okay. Now, when it comes to what we call the alkana and the alkanone, with respect to their nature, there's something that you will hardly notice about them. Despite they share the same chemical, despite they share the same, properties in terms of a functional group, because we say functional groups are atoms or group of atoms that are used to identify the chemical properties or the homologous series of a given organic compound. So, with respect to that functional group, it helps us to know where this particular one belongs to. So it helps us to identify what we call their physical properties as well as what we call their chemical properties. Now, we are going to start now with what we call the preparation of the alkana. How do we prepare the alkana? That is where we are going to start from, preparation of the alkana. Now, under the preparation, before I proceed on the preparation, there's something I want to here, which is very, very important, and you have to know this. What is that? The naming of organic compound is the backbone of organic chemistry. So as a student of chemistry, you are expected to know, or you should be able to name any given organic compound. There are a series of names that you can come across under this mentioned alkana and alkanon. So you have to know how they are being named. Anything can be attached to it, and you are asked to name them. Okay, take for example now, when it comes to alkana and alkanon. Now, if you are given a compound such as this one here, C, then you have double bond O here in this place. Then let's say in this place you have Cl, you have Cl here as well. Then surrounded with H, this is surrounded with H. Now, it is not possible to attach another H to this place anymore and call this alkana. It's not possible. You cannot call it alkana. The reason why you cannot call it alkana is that this is not meant to be written like this. Anything connected to the alkana that you want to write, the CaHO must always be written in the front of the last carbon atom, which is the alpha carbon atom. Is very, very essential. So if you refer to this as alkana, you are wrong. So rather, this one here remain what we call the alkanon. So when you want to name this compound here, 1, 2, and 3. So the longest carbon atom here is 3. So this will be 1, 1, followed by dichloro, followed by dichloro, followed by the longest carbon atom is 3. So the propan 2 on propan 2 on, because the functional group is attached to the carbon atom number 2. Take note of that. It's attached to carbon atom number 2. Okay. So, but when it comes to the alkana, if you want to name the alkana, take for example now, you have C, base. You now have double bond O, then you have H here. You can have Br here, you can have Cl here, or anything that is written there as attachment. Then let's say we surrounded the rest with hydrogen, and hydrogen. Now, what will be the name of this mentioned compound here? The name of this compound, you start from here by numbering 1, 2, 3, 4. So this is chlorine, this is bromine. They are halogens. Alphabetically, bromine comes first before the chlorine. That will be 2-bromo, followed by 2-chloro, followed by the longest carbon atom is what? Is 4. And 4 is what? That is but. That is butanol. Because the functional group is attached to position number 1 of the carbon atom. That is the name of the compound. So these that I've mentioned here, they are the possible compounds that you can come across, those organic compounds that are present there. Okay, what if you are given a structure that looks like this one that I want to draw on the board now? If you are given this type of structure, what will be the name? Such as you can see, the structure you have seen on the board, it represents two things. Number 1, the benzene. Number 2, the aldehyde. But it should be noted that you will not refer to this as benzene in this place. Though, if we take away this, you will refer to this as benzene. Okay. but you are not going to refer to this as benzene because it has been attached to the carbon atom here. You are going to name this compound in form of when you have something like this. And this one here, what do we call this? We call this Phthalate. So if this refers to as Phthalate, then remember the C double bond O followed by H. I have said something connected to it before, which is refers to as what? Methanol. So if you combine the two together, then the name of this compound is called the phthalate methanol. Methanol. As you can see, that is the name of the compound that is present here, the name of this organic compound. So that is how to name the organic compound. Now, let us now proceed on the preparation. So we are going to start with preparation of alkanal. How do we prepare the alkanal? Now, the preparation of alkanal is very, very important in organic chemistry because of the following reasons. It enables us to know those compounds that we need, which are very, very important. And there we go. We're going to start with number one, preparation of alkanal using what we call the primary alkanol in the presence of acidified KMnO4 or K2CR2O7. That is what we need there. Okay. So when it comes to preparation of alkanal, let us begin. I said the number one preparation there is from what we call primary alkanol or primary alcohol. Now from primary alcohol, you used to remember the primary alcohol, they have one alkyl group per carbon atom. Okay, example there is ethanol. Okay, so if they have one alkyl group per carbon atom, then what do we need? In the presence of what we call the K2CR2O7, or we make use of what we call KMnO4, but it must be acidified. Take note of that. It must be acidified. So we have to acidify it so that it can perform what we call oxidation function. So the essence of using this is to carry out what we call oxidation. Okay. So example of primary alkanol that we can use here, we can use such as when we have RCH followed by OH. When you oxidize this in the presence of the given what's it called? In the presence of given agents that we have, either of these two agents, when you acidify it, it will carry out what we call oxidation in the process using what we call the R followed by CHO followed by what we call H2O. That is the product it will form there. This is the general equation for them. Okay, now let us find out from here. We want to prepare one of the compound. If you want to prepare one of the compound with respect to what we have, let's say we want to prepare ethanol. We prepare the ethanol from the ethanol. So CH3 followed by C followed by H2 followed by OH. This formula for ethanol. So when the ethanol reacts together with what we call O under oxidation, take note of that, oxidation, because oxygen is added to it. then what will it produce? It will produce what we call ethanol, CH3, CHO, followed by what? Followed by H2O. So that is the product that will be formed there. So that is the first preparation method that I have there. Take note, oxidation. Now, the next one that we have here now is what we call preparation of alkanone. I want to make it to be more simultaneous so that you can see how those products are being formed there. Take note of that. Preparation of alkanone. So if you want to prepare alkanone, how do you prepare it? Remember the preparation of alkanone. Please, another name for the alkanone, they also refers to as the ketone. While another name for the alkana, they also refers to as aldehyde. So when you come to this place, where can we prepare this one from? Here is the fact. You can prepare them from what we call secondary alkanol. Why? We are very, very much more concerned about what we call the numbers of the carbon atom. So in terms of the numbers of the carbon atom, only those ones that we need that can give us the expected number of carbon atom that we needed. Take for example, now in this place, the alkyl group here is just 1. So it simply means if you had one, if the alkyl group here is 1, it simply means with this one and this one, if you use ethanol as an example, we produce ethanol there. But in a situation whereby we have up to 2, so that the functional group can have position to stay there. So we'll be using what we call from here, from secondary alcohol. From secondary alcohol. That is where we are going to get it from. So the secondary alcohol, same as in the presence of K2Cr2O7 or KMnO4. Now, when you do the same thing, then what will happen? Take note, it must be acidified. It must be acidified. So a sample of the secondary alkanol or the alcohol, we have something like this. Hydrogen. Then, if you react it together with oxygen, as oxidation process, will eventually give rise to CR. Then we are going to have in this place the addition of the compound to it. Remember, what we need here is what is OH. We have our double bond O as usual, and we have our H here. So plus what? H2O. Take for example now, let's say we want to prepare what we call propanol. How do we prepare the propanol? In order to prepare the propanol, we can go in this, which is called the propan 2 none. Rather, we can go in this direction. Excuse me. From here. So we can go in this direction. What direction is that? We are going to have the CH3C followed by OH here, followed by CH3 in this place. We are going to have H here. This is formula for what? For propanol. Now for this propanol that we have, this is formula for what we call propan 2-ol. Pardon me for that. So when you now oxidize this, oxidation, then what will happen? Oxidation, what will happen? It will now produce what we call the, it should be noted, you can put the OH here, you can put the OH here when you arrange it appropriately. So what are we going to have there? We are going to have the CH3, C double bond O, another CH3N plus H2O alongside. This is referred to as the propan 2O that is being produced there. But if you return this to the first carbon atom here, when you return it there, arrange this one as expected of you, you can still obtain what we call the propan 1 or the propanol. So this is oxidation process. Here we make use of what's called the primary alcohol. Here we make use of what we call the secondary alcohol. Take note of that. It's very, very essential. Now we shall proceed. This, if you have 1 or 2 questions you would like to know concerning this topic, you can drop your questions in the comment section. I will definitely attend to that. Thank you very much. Make sure you do that. It's very, very important. Now here we go. Let's talk about this. You can also share this video with 1 or 2 friends of yours that want to actually write JAMB this year, so that they can partake and know more about this. By copying the link, you can share it and do the needful there. Now let's talk about this carefully. When it comes to physical properties, the physical properties of the alkyl and the alkanone. Okay, so here we go. The alkyl, first of all, let's talk about methanol and ethanol. The 2 of them are gases at room temperature. Take note of that. They are gas at room temperature. So other lower molecules, other lower molecules of the alkyl and the alkanols, they are liquid, while the rest of them are solid. So how do I mean? Those that falls in position number 1 and number 2 of the carbon atom of the alkyl and the alkanone, their nature is that they are gaseous. So those that follows, as the number of the carbon atom continue to increase, so also they continue to change from one form to another, that is from one state to another. Now when it comes to chemical properties, number 1 chemical properties is that they can be oxidized. So that is the typical one that we have on the board, which is with respect to their preparation. Of course, you have to know that as well, which is oxidation. When you make use of what we call strong oxidizing agent, let's discuss about this. So when it comes to chemical properties, you have to take note of this very well. The chemical properties of the mentioned alkyl and alkanone. Number 1 is oxidation. So under the chemical properties, where we have oxidation, which simply means addition of oxygen to a compound, removal of hydrogen. In this case, now we make use of what we call in the presence, or using in the presence of what we call the K2Cr2O7 or KMNO4. We refer to them as strong oxidizing agents. So for these strong oxidizing agents that we have there, now take for example now that dealing with the first one, which is called the alkyl. The alkyl, which is CHO. When you oxidize the alkyl, what will be the products that it will form for you? You've already have O here. On adding O to this, what will happen? Nothing is leaving. We are going to have RCOOH. That is it. Look at it carefully. RCHO plus O we give rise to what we call RC double bond OH. So this change from what we call the alkyl to to what we call the alkanoic acid. From alkana to alkanoic acid. That is the transformation that occurred there. So it's an oxidation process. For the second one, when you have RCO, when you oxidize it, what will happen? Under the process of oxidation, when oxygen is added to it, you give rise to RCOO. In organic chemistry, what do we call this? Well, we call this the alkanoids. So from the alkanon to what we call alkanoids. That is exactly what we have here. So a question like this is common under JAM questions, whereby they ask you that when so is oxidized, what happens? When alkana are oxidized, they produce alkanoic acid, and when alkanone are oxidized, they produce what we call alkanoids. So there is no need of any further oxidation process there. But there are some questions that go in this manner. Now, take for example now, if you look at what we have here, we said under the preparation of the alkana, we need the alcohol in order to prepare them, okay? And it can be primary, okay, for the, what's it called, preparation of alkana, and it can be secondary for the preparation of the alkanone. So some typical questions can come in this manner. The complete oxidation, take note, the complete oxidation of primary alcohol will lead to the formation of which products? Now, let's talk about that carefully under what we call complete oxidation. Complete oxidation of alkana. Now, when we say complete oxidation of alkana, complete oxidation of alcohol. Now, first of all, we have what's called the alkanol or the alcohol. Is that you call it complete oxidation of alcohol, or you call it complete oxidation of alkanol? Okay. So in this place, if we oxidize this, first of all, it will produce what we call the alkana. Now, if you now oxidize this further, the last product that it will produce there is called the alkanoic acid. Alkanoic acid. That is what we refer to as complete oxidation. So these are common JAM questions. Okay, the complete oxidation of alkanol will produce what? Will produce alkanoic acid. But if it is partial oxidation, this one will be partial oxidation, while this one will be complete oxidation. Take note of that. It is very, very essential. You have to know what exactly that is formed there. So we have to that carefully. Now, while we proceed, this class will come to an end. Now, let's talk about this now. Reduction process. Now, when it comes to reduction is the reversible case earlier. So you can also reverse them in what sense? If we have oxidation, we can also have what we call reduction process. Okay, so let's talk about this right now. Number 2, reduction. So when we say reduction, what do we mean? Simply means removal of oxygen, addition of hydrogen. So in the case of this compound that we are dealing with under the reduction process, using what we call the LiAl H4, or in the presence of NaBr, okay, BH4. This is what we call lithium tetrahydroaluminate 3, sodium tetrahydroborate 3. These are the reducing agents that we'll be using there. In the presence of these strong reducing agents, what will eventually happen to them when we utilize them? In the presence of these strong reducing agents, we can definitely reduce what we call the alkanal, that is the alkanal, to what we call the alkanol. Take note of that. We can reduce alkanal to alkanol. That is, from what we have here, when we have the alkanal RCHO, they can be reduced, okay? So that is in the presence of hydrogen when the reaction is reversed. So we can reduce what we call the alkanol to alkanol. Take note of that when we reverse the process, okay? We reverse this alkanal, we reverse them back to what's called the alcohol. It's very, very important to have to know what actually happened there. So in the presence of what's called the reducing agents. Here we go. Now this is alkanal in this place. The alkanal that we have there, then we should eventually produce what we call the alkanol, which is R. We can have what we call OH in this place. Don't forget that we are actually dealing with what we call the alkanal. Okay, so that is the exact product that is expected to form there. So in this place now, if we have to look at that, what do we have? You realize that this is what eventually happened there. So take for example now ethanol, CH3 followed by CHO. Now this compound that we have in this place, in the presence of two hydrogen atoms, what eventually happens? Reduction take place, reduction occur. When reduction occurs, it eventually produces CH3 followed by CH2 followed by OH. What do you notice there? You notice that in this place you already have what's called HO in this place already. In order to make this one what we call the ethanol, just add these two, add it together with this one here to eventually form what's called the CH2. So it's balanced the either side there. Now the next one that we have there, which is B. The B now is the case of the alkanone. Alkanone is C, which is RCO. So the RCO, okay, when you make it to undergo the process of reduction, then what will it form? It also form what we call the alkanol, ROH. That is the exact thing that will happen there. So let's find out in this place. Take for example now you are dealing with what we call propanone. Propanone, CH3, CO, CH3. Now, on addition of two hydrogen atoms to base, this will eventually produce what we call the propan2O, CH3, followed by CH, followed by OH, followed by CH3. That is the product that will be formed there. So, with respect to what we have here, this proves to us that there's a reduction taking place in the presence of what we call LiAlH4, okay, as the needed reducing agents in order to get the needed compound. Now, let us proceed. The next thing we have to discuss about is the test to distinguish between the alkanal and the alkanone. What is the test that we need to do here? The test we need to do here is to confirm the differences between the alkana and the alkanone. So in order to distinguish between these two, this is what we have to do. Let's go there. Test for alkana and alkanone. Here we go. Now, there are various reagents that we utilize in this place. First of all, we make use of what we call the reducing now, the first one that we have to talk about is what we call the Fehlin solution. That is Fehlin test. Fehlin solution. Now, what does the Fehlin solution contain? Fehlin solution contains copper 2 complex, that is a copper related compound, which is Cu2 plus. Now, this is the test for what we call the alkana, because the alkanone does not react. Okay, so but the alkana reacts in that place. So in the presence of this mentioned copper 2 complex, there is a formation of another compound there, which changed the color of the Cu2 plus to become the what we call red. Okay, now from here we can have this. When RCHO react together with 2Cu2 plus, then in the presence of what we call NaOH, then addition with water H2O. The product that will be formed will be RCOO minus Na plus plus Cu2O plus what we call 4H plus. That is the compound that will be formed here. Now, in this place, initially, this compound here, this compound that we have here is blue in color. Take note of that, is blue in color. But eventually, when the reaction takes place between the two of them, this one here is oxidized, and eventually it produces this one that is here, which is red in color. So this is the reaction of what we call the copper 2 anions together with what we call the alkana. Take note of that. But alkanone does not react in this manner. Take note of that. Alkanone does not react in this manner. So with respect to what we have here, now, it's that, of course, they react together. Another test that we can have in this place is what we call the tolerance reagents. When you make use of what we call the tolerance reagents. Now, what does the tolerance reagent contain? Now, it should be noted that the tolerance reagents contain what we call the AgNO3, close the bracket, NH3, close the bracket 2. That is what it contains. Now, these tolerance reagents reduce, take note of that, reduce to what we call the metallic silver. Now, this is only done in the presence of the alkana, but not in the presence of the alkanone. Okay, so let us discuss about this further. This reaction here now, how does it take place? Remember that the first one is undergoing what we call reduction, because the Cu2 plus is what? Is oxidized. Take note of that. Okay, so this one as well is also undergoing what we call what? Reduction. So in which this one is reduced to what? To silver. Now this is the reaction that occur between them. So the AgNO3 there, the AgNH3 there represents what we call the reducing agent. So it represents what we call reducing agent. So when such reaction take place, this is what we can obtain from them. We can obtain RCHO, then producing what we call 2AgNH3, close the bracket, 2, then followed by what we call the OH in the compound, eventually form what we call the RCO2, plus what we call RCO2 NH4 plus Ag plus 3 NH3 plus H2O. Now, the compound formed here, take notes. This Tollens reagent is a good oxidizing agent. I have said that earlier. This one is a good oxidizing agent. Take note of that. The AgNH3, close bracket, 2OH. This is called oxidizing agent. So that is it there, the oxidizing agent. And as you can see from here, you realize that the RCHO, is just CH and O. On getting to this place, it has become RCO2. So the number of O there has increased to how many? To 2, increased by a factor of 1. Take note of that one there. So these are the ways that we test for this mentioned compound. So on our next class, we are going to be discussing about compound related to what we call the alkanol. Thank you very much.